Okay, so the first question which I have here is solve each of the following equations. Now I want you to choose.
I have a question.
Yes, please.
Could you tell me
You can see the board.
yeah,
You can see the board, guys.
I think it's not your phone. I can see the board.
I think it's like
Try to log out and then log in again. Try to leave the meeting. Okay, cool. So now from this question, I want you to choose three. So let's do fast. Time. Let's choose three.
question I.
Question I. Uh-huh. Another one to choose. Question I. Where is I? Okay. We have I here. Another one.
We can also do D.
We can also do D. Okay. The last one. Any girl?
E.
E. So let's start with D. Fast. So this is what we call Ladico equations. So under Ladico equations, not all the answers which you are going to find they are the solutions for the equation. You are going to find extraneous answers. Okay? So when you have a Ladico equation, you need to solve the values. You need to find the values of x. Then you have to test them. Because the answers which you are going to be finding, some are not going to be the answers. They're not going to be part of the solution. So let's start with D. So D is saying we have the square root. So allow me to do this. I'll just do this. Okay, so our question D is the square root of 5 minus x plus 1 is equal to x minus 2. I believe you can see my board. Now, what is happening here, guys, is I can see that I have this. What I have to do, I have to shift this one to the other side so that the square root should be alone. In a case where you have got one square root, you need to leave the square root alone. So I'm going to shift positive 1 to the other side. It's going to be like this. X minus 2. If this is positive, if I shift to the right hand side, it's going to be minus 1. So I'm going to have 5 minus x is equal to x minus 3. Up to this point, any question? Now, for me to get rid of this square root, I can just square now. This 2 and the square root will cancel. Here I'm going to remain with 5 minus x. But here I have got x minus 3. This is the same as, it is squared, so it's the same as x minus 3 and then x minus 3. So what I can do, I can expand. I'm going to say x times x is going to give me what? X squared. Then again x times negative 3, I'm going to get negative 3x. At the same time, negative 3 times x is going to give me negative 3x. Then negative 3 times negative 3 is going to give me positive 9. Anyone who is behind in terms of expanding this? We are okay? Okay. Okay, cool. Now from here, what I'm going to do is I'm going to simplify this. I'm going to say it is x squared. Negative 3 minus negative 3 is, or negative 3 minus 3 is 6, negative 6x plus 9. Guys, whenever you see a number alone, you have got only x and x squared. That is a quadratic equation. Okay? Once you see x squared, then you have got another x. Then you have got a number alone without x. That is a quadratic equation. Meaning that I have to shift everything here so that I remain with 0. Because a quadratic equation is in a form of ax plus bx plus c is equal to 0. So I need to remain with 0 this side. It's going to be 0 is equal to x squared minus 6x plus 9. I'm shifting now positive 5 to the other side is going to be minus 5. I shift this x to the other side is going to be plus x. Let me get rid of this. Now from here I can see that this 6x and this they can add. This and this they can add. So I'm going to have 0 is equal to, I'm going to have x squared. Negative 6 plus x is going to give me negative 5x. 9 minus 5 is going to give me 4. Okay? Now at this point I can see that I've got product. The product is positive 4. The sum is negative 5. The factors. Now two numbers which when we do times, those two numbers we need to get positive 4. If we do plus those numbers we need to get negative 5. I can clearly see to say those two numbers we have got negative 4 and negative 1. Because negative 4 times negative 1 is positive 4. It is going to give me the product. Negative 4 minus 4 is negative 5. Okay? If the coefficient here is 1, just get this. You say x minus 4 and x minus 1 is equal to 0. These are your answers. Now, in case you are already confused, allow me to put these ones here. Let me use the method which you know. I'm going to say 0 is equal to x squared. We ignore this. So it's going to give me minus 4x minus x, which is 1 plus 4. So 0 is going to be, I have to factor out x. I'll remain with x minus 4. Here I'll factor out negative 1. I'll remain with x negative there. I'm going to have this. I can clearly see that these are the same. I can pick one. 0 will be equal to x minus 1, x minus 4. That's why I said the factors which you are going to find here, if the coefficient here is 1, positive 1, just get those factors to say x minus 1 and x minus 4. They are going to be your solutions. Are we together?
Yes, we are together.
Yes. Now at this point what I'm going to do, guys, is I have to, this is the same as x minus 1 is equal to 0, x minus 4 is equal to 0. Meaning x has to be equal to 1 and x has to be equal to 4. I have got two values, but these are not my answers. I have to test them. Unless you have questions. So I'll get rid of this. I'll get rid of this and I'll get rid of this. We have found that x should be equal to 1 and x should be equal to 4. So let's see. Is this true? So we have got the square root of 5. Let's put 1 where there's x. Plus 1 is equal to, let's put 1 minus 2. So what is the square root of, this is going to give me 5. 5 minus 1 is 4. What is the square root of 4? Is 2. 2 plus 1 is going to give me 3. So here I've got negative 1. So is 3 equal to negative 1? Is 3 equal to negative 1? I'm asking, guys. To the left hand side we are finding 3. To the right hand side we are finding negative 1. So x is equal to 1 is not the solution for this equation. Let's try 4. If I put 4 where there is x, am I going to get the same left hand side and right hand side? So in the square root here, 5 minus 4 plus 1 is equal to x. Where there is x, we put 5. It's going to give me 5 minus 2. So here I'm going to have what? 5 minus 1 is going to be 1. The square root of 1 is going to be 1. So it's going to be 1 plus 2. It's going to give us what? It's going to give me 2. Here I'm going to have 3. Is 2 equal to 3? So again, x is equal to 4. X is equal to 4 is not the solution for this equation. Therefore, this equation has got no solution. because if I plug in x is equal to 1 and x is equal to 4, it's not giving me the answer. So x is equal to 1 is not the solution, x is equal to 4 is not the solution.
There's a question, sir.
Yes, please.
What about here on the second line where we have put 5 minus 2? Why didn't we put 4?
Oh, sorry. Yeah, it's supposed to be 4. Thank you, thank you. I was thinking maybe where there's x we are putting 5. So I wanted to be shocked to say this is 1 has to be the solution. So we are putting 4, right? It's 4 minus 2, right? So here 5 minus 4 is giving us 1. The square root of 1 is 1, so it's going to be 1 plus 1 is equal to 2. Okay, 2 is equal to 2. So the only solution for this equation is x is equal to 4. Yeah. It's making sense now, right?
Yes.
Yes. So x is equal to 4 is the only solution for this equation. Okay. Next, you told me that we should solve E. Let's go ahead and solve E. Shit. Are you getting me?
Yes, I can get you.
Okay.
Yes, we're getting it.
Okay, so let's go to the next one. Okay. Just a minute. Let me put my phone on do not disturb. Okay, cool. So now the next one is a big square root. Then inside there is a small square root of x minus 5 plus, what's this? Plus x is equal to 5. Here, guys, if you have got one square root, this side you don't have any number, just square. So here I'm going to square. Even here I'm going to square. So these two and the big square root, they are going to be removed. I'm going to remain with this x minus 5, the square root inside, because this 2 is just cancelling out with the big square root. So I'm going to have this is equal to 5 squared is 25. Now remember I said you need to have only one square root to the other side. If you have got one square root, then you need to shift the rest to the other side so that you need to have one square root. So I'm going to shift this to the right hand side so that I remain with x minus 5 is going to be equal to 25. I'll have 25 minus x. I've shifted this to the right hand side. At this point now I can do what? I can square again. Even here I can square. Now squaring this is going to give me x minus 5 to be equal to, this one is going to be 25 times 25 is what? What is 25 times 25? 625, right? Then 25 times x is going to be negative 25x. Then x, negative x times 25 is going to be negative 25x. X times x is going to be this. Remember I said as long as you have got x, x is existing, x squared is existing, and just a number, that is definitely a quadratic equation. So I'm going to shift everything here to remain with 0. Then I'm going to say 0 is equal to 625 minus, if I can add these I can get a 50x plus x squared. If I shift x to the other side, is going to be negative x plus 5. Now I can see I've got the right terms here, this guy and this guy. At the same time, this guy and this guy. Okay, so I have 0 is equal to 625 minus 625 plus 5. It's going to give us 630, right?
6, 8, yeah.
630. Then negative 50x minus x is going to give me negative 51x plus x squared.
Yeah.
So what I'm going to have now here, let me write it from here. I've got my quadratic equation as x squared minus 51x plus 630 is equal to 0. at this point I can now see that I've got my let me just do this. I'll have my product and the sum, then I need to have factors. So my product is 630, my sum is negative 51. So now, what will be our factors? Two numbers which when we do times we get 630. If you're having challenges on how to find the factors, you can just be using the long division. But anyway, here we can find the factors. What will be our factors? What will be our factors? Anyone?
Negative 30 and negative 21.
Exactly. Negative 30 and negative 21. If I say negative 30, if I say negative 30 minus 21, I'm going to get the sum, which is negative 51. Negative 30 times 21 is going to give me positive 630. Like I said, if the coefficient here is 1, you just get this x minus, I'm going to have this x minus 21 is equal to 0, because the coefficient here is positive 1. So allow me to get rid of this to finish this question from this side. So I'm going to have my x minus 30 to be equal to 0 and x minus 21 to be equal to 0. So x will be equal to 30, x will be equal to 21. But these are not answers. Because it's a radical equation, we have to test. So I'll write them here. Let's now test. Our equation is a big square root, then a small square root of x minus 5 plus x is equal to 5. Let's start with 30. Okay? So inside here, if I put 30, 30 minus 5 plus 30. So what is 30 minus 5? 30 minus 5 is going to give us what? It's going to give us 25. What is the square root of 25? 5. So meaning I've got 5 plus 30. So what is 5 plus 30? 35. Do you think the square root the square root of 35 is going to give us 5? No, because the square root of 25 is the one which is going to give us 25. So x is equal to 30 is not the solution. I go to 21. Have you seen what we have done? Yes. So now I'll go to 21. Now if I plug in 21 here, yes please, you can ask. 21 minus 5 plus x, or x is now 21 as well. Yes please, you can ask. Do you have questions? Okay, so 21 minus 5 is going to give us what? What is going to give us what? 16, right? Yes. So what is the square root of 16? Square root of 16 is 4, right? 4 plus 21 is what? 25. What is the square root of 25?
5.
5 is equal to 5. So we can see that it's giving us 5, the answer 5 here. So x is equal to 21 is the only solution for this equation. Is that okay? Yes. Yes. What about what? You just say the only solution for this equation is x is equal to 21. That will be the conclusion. You get it, huh? Yes, yes. You just say the only solution for this equation is x is equal to 21. So now let's do I. We have got 2 square root. I want you to get this point here. We have got 2 square root. Now, if you have got 2 square root, you need to shift one square root to the other side so that you have got a square root to the left hand side and another square root to the right hand side. If you have got 2 square root. So I'm going to shift this guy so that it should go to the right hand side. So I'm going to say 11 minus x is going to be equal to 3 plus the square root of x plus 6. At this point now, I can square. If I square this and this will cancel, so I'm going to have 11 minus x. But here is the issue. This part here is going to be 3 times everything here in the square root is going to give me 3 the square root of x plus 6. Then I'm going to say, or I can start with 3 itself. Okay, 3 times 3 is going to give me 9. Then 3 times the square root here is going to be 3 the root of x plus 6. Again, the root of x plus 6 times 3 is going to give me 3 the root of x plus 6. Then the root of x plus 6 times the root of x plus 6, the root will go and I'll have plus open brackets x plus 6. You have to put brackets because in a case where you are going to have a negative here, this negative is going to affect everything here. That's why I'm putting the brackets. So to simplify this, I'm going to say x minus or 11 minus x is going to be 9 plus these I can add. It's going to give me 6 the root of x plus 6 plus x plus 6. Now I can clearly see here that I've got 9 here, I've got 6 here. I can add them. So it's going to be 11 minus x will be equal to 9 plus 6 is going to give me what? 15. Plus I can put x here, then I have got plus 6 the root of x plus 6. Okay. Now remember I said if you have got one square root, what do? You have to shift everything to the other side so that you remain with the square root alone, right? That's what I said. So in this case, I'm going to shift these two guys so that they go to the left hand side. So I'm going to have 11 minus x. I shift 15 is going to be minus 15 minus x is equal to the square root of 6, the square root of x plus 6. Now I can add these two. This and this can be added. This and this can be added. So I can get rid of this. I'm going to have 11 minus 15 is going to give me minus 4. Then negative x minus x is going to give me negative 2x is equal to 6 the root of x plus 6. Now I can clearly see that I only have one square root. I can now square to remove the square root. So squaring this is going to be negative 4 times negative 4 is going to give me positive 16. Negative 4 times negative 2x is going to give me positive 8x. Then negative 2x times negative 4 is going to give me positive 2x or positive 8x, sorry. Negative 2x times negative 2x is going to give me positive 4x squared. This has to be equal to, what it means here, I'm squaring 6, the square root of x plus 6, meaning that I have to square 6, I have to square this. So it's going to be 6 squared is 36. Then if I square this, meaning the square root will be removed, I will say x plus 6. Anyone who is behind? You are behind from the you are behind from the part I started writing. Okay, let's do this. But you're okay where I'm squaring these guys, right?
Very sure.
So what I'm doing here, sir, is I'm going to say negative 4 times negative 4 is positive 16 because it is squared. Then I'm going to say negative 4 times negative 2x is going to give me positive 8x. Are we together?
Sure.
I'm done with 4. Then I'm going to say negative 2x times negative 4 is going to give me positive 8x. Are we together? Negative 2x times negative 2x is going to give me positive 4x squared. Then this has to be equal to, I have to square 6. 6 squared is 36. If I square the square root is going to be x plus 6. But I have to put them in square root because, or I have to put them in brackets because it is multiplying with the 6 outside, the 36 outside. What did I say? The moment you see x squared, you see another x existing and a number. What comes in your mind? It's a quadratic equation, exactly. Meaning that these two, I can add them. It's going to be 16. Patience, you can kindly mute your mic. Sure. So it's going to be 16. I add 8 plus 8 is going to be 16x plus 4x squared. This has to be equal to 36 times x is going to be 36x plus 36 times 6. What is 36 times 6? Is 216. Yes. Now I have to shift everything here to the left hand side so that I remain with 0 because this is a quadratic equation. So 16 plus 16x plus 4x squared minus 36x minus 216 has to be equal to 0. I can clearly see that this guy and this guy can add, this guy and this guy can add. There we go. So what is 16? I can start writing, I'll say 4x squared. I've started with this. Okay. So what is 16x minus 36x? Negative what? Negative 20, right? Negative 20, not so?
Yes.
Negative 20x. So what is 16 minus 216? This has to be negative 200. Has to be equal to 0. Now at this point, allow me to get rid of this so that I create space. Okay. So now I have got my equation, which is 4x squared minus 20x minus 200 is equal to 0. I can see that I can divide everywhere with 4 so that I reduce this. I'm going to say divide by 4, divided by 4, even here by 4, even here by 4. So 4 there is going to be x squared, 4 there is 5x, 4 there is going to be what? 4 into 25, right? It's going to be 50, right? Is equal to 0. Now I've got my simple equation, quadratic equation. The product is negative 50. The sum is negative 5. What will be my factors? My factors are going to be negative 10 and positive 5, not so? Huh? Negative 10 and positive 5. I clearly said if the coefficient is positive 1, just get x and the sign you have there, plus 10. Then here I'm going to say x plus 5 is equal to 0. They don't give marks where you say x squared, then you start now doing this. They don't give marks. Then you start now simplifying from here. Then here I say I factor out 5. Then x minus 10. They don't give marks here. You can just come direct here. But if you are confused, you can just be doing this. Don't skip this stage. You can put it there. It's okay. Okay? So meaning that my x will be equal to 10 and another x will be equal to negative 5. Are we together there? I don't know if you are confused.
No, we are not.
Okay, perfect. It's good that you're not following. But are we together up to this point?
Yes.
Okay. So here, since these are the same, I'll pick one. I'll just say x plus 5. Then I'll say x minus 10 is equal to 0. Then I'll say I'm going to have x plus 5 is equal to 0, comma x minus 10 is equal to 0. I solve for x. Okay, meaning what I have to do now is I want to get rid of this. I no longer need this. So I have got my equation, which is x plus 5 is equal to 0. So I can solve x. X will be equal to negative 5. I have another one, x minus 10 is equal to 0. I can solve x will be equal to 10. Are we together there?
Yes.
Are these our answers?
No.
What almost?
We need
We need to prove them. So we have got x is equal to negative 5 and x is equal to 10. So I'll go there and prove. So I'm going to say I have got the square root of 11 minus x minus the square root of x plus 6. They are saying that it should give us 3. Let's start with negative 5. If I put negative 5 where there is x here, negative will give me positive, minus. If I put negative 5 plus 6, this inside here I'm going to get 16, right? What is the square root of 16? 4. Minus. Here I'm going to have negative 5 plus 6 is going to give me 1. What is the square root of 1? 1. 4 minus 1 is what? 3. So indeed, x is equal to 5 is the solution for this equation. Let's try 10. We try 10. If I put 10, here is going to be minus 10 minus, I have got 10 plus 16. So what is here? I'm going to have 11 minus 10 is 1. The square root of 1 is 1 minus 10 plus 6 is 16. The square root of 16 is 4. I'm getting negative 3. Is negative 3 equal to 3? No. So x is equal to 10 is not my solution. You say the only solution for this equation is x is equal to negative 5. In general, now you can solve any type of radical equation. Let me show you the question which is in 1010. The question which is from 1010, where is that question? Okay, so in tutorial sheet for 1100, there's a question for the same thing, how to solve these radical equations. I think I've not gotten it from here. It's not here. Okay, it's not here. Yeah, so you can solve those questions, but in fact that question they clearly indicated to say identify the extraneous answers. So the extraneous answers is the answer which you have found, but it's not part of the solution. Okay, now that we have talked about radical equations, let's now talk about how to find the domain and range of the let's talk about the domain, how to find the domain and range, and also how to sketch the radical functions. Okay, so here I want you to choose one. Okay, choose two. Choose two.
B.
Mm-hmm.
Question A and C.
You don't want question. Okay. Okay, let's do also A. So how do we find the domain of the radical function? What we normally do here is you can never have the square root of a negative. Okay, this is undefined. If you punch using your calculator, you are going to see that any number, as long as you square root that number is having a negative, it is undefined. So we are trying to run away from the undefined. We want to make the function to be defined. Therefore, I have to get what is inside the square root only what is inside the square root, I have to equate it greater than or equal to 0, solve for x. So in this case, I'm going to say 3 plus x greater than or equal to 0. I have to solve for x. X greater than or equal to negative 3. We are trying to find the domain, meaning that the domain, it has to start, if I say greater than or equal to, meaning that number is included. So I'm going to say my domain in this case is from negative 3 all the way to positive infinity. But negative 3 has to be included. I should only, for this function to be defined, the only numbers I should plug in there is supposed to start from negative 3 all the way to positive infinity. Any number less than negative 3, the function is going to be undefined. We can even try. Okay? Which number do you think we can put there? Any number less than negative 3. Let's say negative 4. If I put negative 4 there, which is less than, it's going to give me this. It's going to give me the square root of negative 1. So the square root of negative 1 is undefined. Okay? So in this case, our domain is from negative 3 all the way to positive infinity. Now, how do we find the range? You can find the range. The easiest way for you to find the range is just have this. You need to have your coordinates. We are saying that x has to be greater than or equal to negative 3. I'm going to put it here. So I'm going to put it there. I'm going to say I'm going to have my x. I'm going to have my x and y. I'm going to have my x and y. Now, the domain here is telling me to say the values of x should be greater than or equal to negative 3. I have to start from negative 3. So I'm going to choose numbers. I'm going just to choose 3 numbers, which is greater than or equal to negative 3, starting from negative 3. Next, I'm going to go to negative 2. Next, I'm going to go to negative 1. If I want, I can even include 0 so that I put 4. Okay? But the best way to do here, guys, is this. You can put these numbers quite okay. But the best thing which I can tell you here is that since you have got this is the same as y is equal to the square root of 3 plus x. Okay? So it's okay for you to be putting numbers which is going to be giving you at the square root, because you don't use a calculator. So I'm going to be choosing numbers which are going to be giving me the square root. For example, here I'm going to say if I plug in 3, okay, if I plug in negative 3 in this where there's x, what will be my answer inside there? 3 minus 3 is going to be 0. The square root of 0 is 0. Okay? Next, if I plug in negative 2, it's going to give me 1. The square root of 1 is 1. But if I put negative 1 there, it's going to give me 2. The square root of 2 we don't know. So I'm going to shift and then I'll pick a number which is going to give me the square root. What if I put 0? 0 is going to fail. What if I put 1? 1 is going to give me 4, right? Yeah, if I put 1, it's going to be 3 plus 1 is going to be 4. The square root of 4 is 2. That's all. I'll end there. Now, we can see the values of y that they are starting from 0 going up there. Okay?
Yes.
They're starting, so you are going to say that y has to be greater than or equal to, we are starting from 0, greater than or equal to 0. That is your range. Meaning your range now is going to be starting from 0 all the way to positive infinity. That is my range. Now, how do we sketch? You sketch using these coordinates which we have just come up with here. So my range, let me put it here. I'll sketch using this. I'll say my graph is going to be like this. In x-axis, I have got negative 3, negative, I've got 1 here. I'm going to have negative 2 there. I'm going to have 3 there. Okay? But if you want, you can put 1, 2, 3, 4, 5, just like that. It's okay. So I've got a 1 here, a negative 2 here, a negative 3. In y-axis, I've got 0, 1, and 2. So I'll start. What is 0 comma negative 3? It is at this point. Negative 1 comma negative 2 comma 1, it is at this point. 1 comma 2, it is at this point. My graph starting from this point going in that direction. I have to put the arrow showing that I don't know where the graph is ending. And we can see from here that the domain is starting from the domain is the x values. So the x values, they're starting from negative 3 going to positive infinity. The y values, they're starting from this line from 0 going to positive infinity. So that's how you graph, that's how you sketch radical functions. Unless you have got questions, we can go to B.
Yes, we can go to B.
Okay, let's go to B. So B is saying we have got the f of x to be equal to 3 minus the square root of 1 minus 2x. Now, you only get the part which is in the square root for you to find the domain. So you say 1 minus 2x has to be greater than or equal to 0. So for x, I'm going to shift this one to the other side. It's going to give me negative 2x greater than or equal to negative 1. So I have to divide both sides by negative 2. Once I divide by negative 2 here, this sign changes. Okay, so these two will cancel. I have x, this sign is going to change because I've divided with what? A negative. It's going to be less than or equal to 1 over 2. Okay, so my domain now is telling me to say x has to be less than or equal to half, meaning starting from negative infinity all the way to half, but this has to be included. It's no longer greater than, it is less than. Okay, how do we find the range? I'll have my coordinate x, y. First, I have to plug in the first value here of x, which is half. If I plug in half, what will be my value for y here? But let me first do this. Allow me to get rid of this. Remember, we have y is equal to 3 minus, yes, you can move. So I have got 3, the square root of, I've got 3 the square root of 1 minus 2x. So if I put where there's x, I put half. You are going to see that in the square root there, 2 and 2 will cancel. I'm going to have 1 minus 1, which is going to be 0. The square root of 0 is what? 0. So it's going to be 3 minus 0. You include now this 3. 3 minus 0 is going to give me 3. Is that okay? I'm going to pick another number. That number has to be less than half. But when I plug in that number, I need to get the square root of that number. So let's get negative 1. If I get negative 1, 0 is not going to work out. But I have to get what? Negative 1. So if I get negative 1, it's going to give me 1 plus 2. Negative 1 is not going to work out. What number can we get so that we get a square root of that number? That number has to be less than half. Let's get negative what? If I get negative 2, it's not going to work out. Negative 3 is going to be 6. And 6 plus that one is going to give me 7. But if I get 4, it's going to work out. If I get negative 4. So negative 4 times that one is going to give me 1 plus 8. So 1 plus 8 is going to give me 9. Are we together there? I'm going to get 9. So the square root of 9 is going to give me what? What is the square root of 9? 3. 3 minus 3 is 0. So I'm going to have 0 here. Even here, you can just have even 2. They are enough. You can clearly see that you are starting from 3, but it's going down. What does it tell us? It tells us that y has to be less than or equal to 3 because it is going down. Okay? Yes. So meaning that my range is going to be from negative infinity all the way to 3, but 3 has to be included. Now, how do we sketch this? This is going to go like this. If you want, you can put 3 coordinates. That is just okay. So I've got in x, I'm going to have half here. I've got -4. Then in y, I'm starting from 3. So 3, I'll put 3 here. But I can put, if I want, I can put this to show that that is where it's going to start from. Okay. So I've got half comma 3, it is at this point. Then I also have -4 comma 0, it is at this point. We can clearly see that our graph will move like this. Okay, so that is the sketching of that one, meaning that even part C you can solve using the same principle. You can solve part C, not so?
Let us do it. Let us do it together.
We do it together. I'm looking at time. I wanted us to do some other things. Okay, let's do.
All right.
Yeah, I'm looking at time. I think this one you can do using the same principle. Yes. Now let's talk about how do we sketch here. Here is another question. That this is now a rational function. How do we sketch rational function? Choose 2 questions here. These questions I've gotten them from tutorial sheet for 1100. I should get C. Okay. Okay. So let's do this. You have chosen one, so another person can choose another question.
One question D.
D. Okay. Rational function. When you are graphing rational functions, you need to know how to find the intercept. You need to know how to find the domain and the range. Anyway, you need also to know how to find the asymptote. Okay. So let's start with how do we find the domain. In this question, they didn't ask us to find the domain, but for 1100, for 1120, they clearly indicate to say find the domain and the range, and also find the asymptote. But in this case, they are just asking us to find it. In case you don't know, if you know how to find the domain and how to find the range of the rational function, believe me, you know how to find the asymptote. Let's start with part D, then we go to part A, or to part C. We have got our function f of x to be equal to x divided by x squared minus 9. To find the domain, or let me say to find the vertical asymptote, we have got 2. We have got the vertical asymptote and horizontal asymptote. To find the vertical asymptote, get the denominator, set it equal to 0, solve for x. I'm going to say x squared minus 9 is equal to 0. X squared is equal to 9. I get the square root both sides. Immediately this is going to be plus or minus. So x will be plus or minus 3. So I've got my vertical asymptote at -3 and +3. Guys, the way I've done it, finding the vertical asymptote, when you can mute your mic.
Yes.
Yes. Finding the domain, the vertical asymptote and the domain, they are the same. You say, you equate this not equal to 0, so you say not equal to 0, meaning that your domain is x should not be equal to plus or minus 3. That's why I was telling you to say, if you know how to find the domain, then you know how to find the vertical asymptote of the rational function.
Okay.
Yes. So in this case, that is my domain, meaning my domain, x is such that x should not be equal to plus or minus 3. X should be a member of all real numbers. If you want, you can put your domain in set interval notation. You say from negative infinity all the way to -3, but -3 is not included, union from -3 to 3, but these are not included, union from 3 all the way to positive infinity. That is my domain. I'm kindly asking if you can mute your mic. Okay. Now, let's go now to the vertical asymptote. Sorry, the horizontal asymptote, I mean. How do we find the horizontal asymptote? We have got 3 principles. If the function is bottom heavy, if the denominator has got the highest degree of power of x, the horizontal asymptote is 0. At the same time, if you want to find the range, that is your range, you say y is not equal to 0. That is your range. Okay? In a case you have got a situation, let me give you this. In a case where you have got x squared divided by x squared minus 1, the powers of the numerator of x and the denominator, they are the same. Then you get the coefficient, you divide them for you to find the horizontal asymptote. In this case, meaning my horizontal asymptote is going to be 1 divided by 1 is going to be 1. In a case where you have got 3 here, you have got 2, you are going to say 3 divided by 2. If the numerator and the denominator, they are having the same number of what? The powers of x. You just get the coefficient, divide them. Okay? In a case where you have got the denominator has got the highest degree of power of x, the horizontal asymptote is 0. Now, in a case where this case, even if they don't bring it, the numerator has got the highest number of power of x, you don't have the horizontal asymptote. There is no horizontal asymptote. Those are the only 3 principles which you have to know under rational function. Okay? So in this case, our function, we can clearly see that we have this. Our horizontal asymptote is going to be 0 because on the denominator we have got x to the power 2, but on the numerator we have got just x. So the horizontal asymptote is 0. Now let's go on intercept. How do we find the intercept? To find the x-intercept, equate y equal to 0 and solve for x. In that case, I'm going to say the equation is y is equal to x divided by x squared minus 9. Where there's y, let's put 0. X divided by x squared minus 9. Let's cross multiply. So if I cross multiply, I'm going to have x. If I do 0 times everything on the denominator, is going to give me 0. So I've got my intercept at x is equal to 0. So when x is equal to 0, y was equal to 0. So you can say it is 0 at 0, 0. Is that okay? To find the y-intercept, equate x to be 0. To find the y-intercept, x has to be equal to 0. So I'm going to say y is equal to, where there is x, let's put 0. I'm going to put 0, 0 squared minus 9. So I'm going to have y is equal to what? 0 over negative 9. 0 over anything is 0. So again, I'm going to have 0, 0. Is that okay?
Yes.
Up to this point, do you guys have questions before?
Just to draw you back a bit, on y, I'm okay where we have arrived to solve y, but for x, I think I've missed it.
You have missed it, eh? Okay. How to solve? You're okay with this one, right?
Yes, I'm okay with this one.
Okay. So now to find the x-intercept, equate y to be equal to 0. So our function is y is equal to x divided by x squared minus 9. So where there is y, just put 0 and solve for x. So I've got 0 is equal to x divided by x squared minus 9. We are together there, right? Now I'm going to divide here by 1, so I have to cross multiply. Meaning x times 1 on the denominator is going to give me x. Then 0 times everything here is going to give me 0. You okay? Before we go anywhere, please ask. We are about to sketch the graph. Yes, we are about to sketch the graph. If you have got questions, please ask. We can continue, right?
Yes.
Okay, so there we go. So I have my points at 0, 0 only. So this is what I'm going to do. This is the simplest method you need to know. So I'm going to have this. I'll have this. My vertical asymptote is at -3 and 3. Let's put 3 here and let's put -3 here. Meaning it's not supposed to touch this line. It's not supposed to touch this line. In a case where you have got two vertical asymptotes, the graph is going to touch the horizontal asymptote. That is the principle. And the horizontal asymptote is at 0. I'm going to have there. Now, I have got my 2 points. Okay? My intercept is at 0, 0. Where do we find 0, 0? It is at this point. Okay? Again, 0, 0, another one, I'm going to find it the way it is. Now, I've got 1 point. Okay? If I've got 1 point here, I can clearly see that my graph has to start from this point. It has to come here and touch there, then comes here. Okay? So, I'll put the arrows because I don't know where it is ending. Now, another point which you have to take note here is that the curve, where it is making a curve here, there is a curve here. Let me show it in this color. There is a curve here, this curve. Okay? It has to reflect to the other side. If you have got a graph, let me just give an example here. If I've got my graph, this part here, this has to be reflected to the other side, meaning I'm going to put it there again. If I've got my graph this side, it has to be reflected there. I need to follow the curve. So in this part here, I'm going to follow this curve and say, this curve here, I've got a curve this part, so this is going to be reflected here. I'm going to have another part here. Again, I've got a curve there, and I'm going to reflect it to that other side, this side. That is going to be my graph. That is first method. Brown. Now, if you watch my video, the one I explained about graphing rational functions, I posted it yesterday. I solved a lot of questions. Okay? Now, I want you to see how question C is going. Oh, before we do that, let's do question A. I want you to see how question A is going to come about. I want you to be telling me what to do. We want to find the asymptote. To find the vertical asymptote, we get the denominator, we set it equal to 0. So for x is equal to 2. We are okay there, right? That is my vertical asymptote is at 2. What is my horizontal asymptote? Come on. What is my horizontal asymptote? 0. Because the denominator's got the highest degree of x. Now, let's find the intercept. To find the x-intercept, we said equate y to be equal to 0. So it's going to be y is equal to 1 over x plus 2. 0 is equal to 1 divided by x plus 2. Let's cross multiply. If I cross multiply here, guys, I'm going to say that 1 will be equal to, this times 0 here is going to give me 0. 1 is equal to 0. That is not true. If x doesn't exist, meaning that there is, you just lie to say no x-intercept. We don't have x-intercept there. Is that okay? No x-intercept. Next, I have to find the y-intercept. How do we find the y-intercept? To find the y-intercept, set x to be equal to 0. So let me just say, for you to find the y-intercept, set x equal to 0. So for what? For y. So y will be equal to 1. Where there's x, I'm going to put this. I can see clearly that y will be equal to 1 over 2. So when x is equal to 0, y is half. That is the only intercept we have. So you are going to say I've got my intercept at y is equal to half. After finding this, you are done, guys. You are done. You are going to say, I have this, I come here, then I'm going to say I have my vertical asymptote at 2. I'm going to put my 2 here. There we go. My horizontal asymptote is at 0. Okay. What next? What next? I have got my coordinate. My coordinate is at 0, half. Where can I find 0, half? On top here, not so. I can find a half somewhere here. So 0, half is going to be at this point. I have got only one point. What it means there is that I've got my vertical asymptote here, horizontal asymptote. It's supposed to, then it touches there, running away there. That has just helped me to find the one side, but it has to be reflected. This is the curve. It has to be reflected to the other side. Then I'm going to say another curve is going to be there. That is going to be my graph. Unless if you are confused. Are you confused? Do you want me to teach you another method on how to sketch this? Huh? Is this method enough for you, or you need another method?
Professor, we need another method then.
You need another method. Okay, let me show you another method. So another method is where you don't use the intercept. What I'm going to teach you now here is this. But here, if they ask you to say find the intercept, you have found that you have at y is equal to 1 over 2 and you don't have x intercept. Then you are going to say your vertical asymptote. You have to do this. I'm going to have my x, y. My vertical asymptote, we have found that it is 2. You get my point, eh? So when plugging in because it's not supposed to touch 2, when plugging in the values, what we normally do here is you have to get two numbers. I have got, this is a 2. I have to get two numbers right and two numbers left. Okay, but I have to skip this. So I'm going to say I'm going to get two numbers left, which is going to be, I have to get 0 and what? 0 and what? 0 and 1. That is left. If I want to get the numbers right, it's going to be, I'm going to get 3 and 4. Are we okay there? I don't have to plug in the vertical asymptote because x should not be equal to vertical asymptote. Is that okay? Yes. Now I'm going to come here and say my function is y is equal to 1 over x plus 2. Where there is x, if we put 2. Wait.
I can't get you.
My line is breaking? Or maybe it's just your network. You guys, our vertical asymptote, was it negative? Our vertical asymptote was supposed to be negative and not positive. Because x plus 2 is equal to 0. So x is going to be equal to negative 2. Did we, when sketching, did we use negative 2 or positive 2? We used positive, so that was wrong. So just a correction. We need to use negative 2. So vertical asymptote has to be negative 2. So it's going to be like this. At negative 2, then we need to have this. Okay? And we also have another one at 0. So we have 0, negative half is going to be at this point. So it's supposed to start from there, cutting there, going there. You put the arrows. Then it is going to be reflected this side, which is going to be like this. Have you seen? Yes. Now, This method which I was showing you here is going to come out exactly like the way we have done it. Let me show you now. I've gotten two numbers left and two numbers right. So now it is -2. Let me restart it. We are saying that our vertical asymptote is at -2. So I'm going to get, I've got -2, two numbers right, two numbers left. So here I'm going to get negative what? -4 and -3. Here I'm going to get -1 and 0. That's all. So I'm going to put here x, y. So where there's x, I'm going to put -4, -3. I'll jump to -1 and 0. That's all. Then let's plug in these values in our equation. So if I put -4 here, it's going to be 1, -4 plus 2. It's going to give me 1 divided by -2, right? Not so. So I'm going to have, when x is equal to -4, I'm going to have -1 over 2. Let's now plug in -3. If I put -3, you guys can clearly see that I'm going to have 1, -3 plus 2, 1 divided by -1, which is going to be what? -1. If I put -1, what if where there's x I put -1, it's going to be 1 divided by 1, right? 1. If I put 0, it's going to be half. And you can clearly see that our our intercept was at 0, half, and we still have this point. Then after finding these to my coordinate, you just come here and say my vertical asymptote is at -2. I'll put -2 here. Then let me put -3 and -4 there and -1 here. Let me put, okay, that is the only thing which I have. So I'm going to put -1, -2, -3, -4.
-4.
Exactly. 1, 2, 3. Let's just put there. So in y-axis we have what? -half. But let me first put -2 as my vertical asymptote there, and also my horizontal asymptote as at 0. So I'm going to start now. Let me put, I have got -1. Let me put half. Let's start with half. Then let's put, let me do this. I'll put half here. Then let me put -1 here. So I've got -half and 1, -1. Even here, positive half and 1. So the first point which we have to plot here, guys, is -4, half. -4, half is at this point. Next, I've got -3, -1. -3, -1, it is at this point.
Yes.
I can clearly that it is starting from there, it has to touch these 2 points. Starting from there, touching these points, going there. I'm done. Next, I'm going to -1, -1. -1, -1. In x, okay. -1, -1, it is at this point. Then I also have 0, half, it is at this point. Starting from there, touching these two guys, going there. Which one is simple? So which one is easy for you?
The second one.
So the second one, you need to be careful. If you have got two vertical asymptote, you have to get, for example, let's say you have got your vertical asymptote at 3, like in that case we had -3 and 3. You have to get two numbers right, two numbers left. That is -3 alone. Again, you have, for 3 you have to get two numbers right, two numbers left. Plug in there. It's going to come out perfect. So right now I'm tired. I think we can continue tomorrow. But I can clearly see that we are supposed to solve this for 1100. And then this one we are going to do it tomorrow. Then we can also do this tomorrow for inequalities. But before we go, I think it is my duty now to advertise my business. So for those who are not registered with Transcended, it is high time you can you can now join us.
Okay.
Yes, it is just 100 kwacha per course per month. If you pay that 100 kwacha, you are going to access everything in math, from sets to where we are right now. I don't know if we are on trig or calculus. You are going to access everything actually,
Okay.
even the recorded classes, even the videos which you have, the tutorial sheets, the past papers. You are going to access in just that 100 kwacha. In physics, in that 100 kwacha, you are going to access from vectors all the way to circular motion, or let me say rotation, work, energy, and power, including tutorial sheet. I also do solve the past paper questions. You are going to be accessing all those stuffs. Okay.
All right.
Yes. So tomorrow same time, it's going to be free tomorrow. I'm a nice person, by the way. Tomorrow is going to be free as well, so you are most welcome again. You should join tomorrow.
All right. Thank
All
you
right.
so much.
Thanks.
Sure. Have a blessed night.